Okay, I don't have my notes with me, but I wanted to give y'all an explanation of exponential functions so that you could possibly understand your notes a little bit better. So as far as exponential functions go, okay, you're going to have exponential growth, which is a curve going upwards, or you're going to have exponential decay, which is a curve going downwards. Now, what I want you to make sure you understand is that this exponential growth curve right here, as it goes backwards, it's getting closer and closer to this x-axis, to the negative x, but it never reaches it. We call that an asymptote, okay? And in this case, this curve is, decay curve is getting closer and closer to the x-axis, but still never reaches it. It's still an asymptote. The x-axis would be the asymptote in this case. This is a term that we've just recently added into Algebra 1 curriculum, and you will be seeing it more in Algebra 2 as well as Pre-Cal if you take those classes. But just remember, your asymptote is a line that a function is approaching but never touches, never reaches it. Okay, now then, something else I want you to remember is that if you have a growth curve, you have an equation where the b in the situation is greater than 1. Growth b is greater than 1. Okay? If it's decay, go at getting smaller, then b is less than 1. All right, now, how do we get that b? It's represented by 1 plus a rate in change. That's in those parentheses. So when you saw that second equation that I gave you, other than this one, this is the completed one after you've added or subtracted your rate of change from 1. That's how you get b. So you can add or subtract the rate, adding if it's growing, subtracting if it's decreasing or decaying, and then this is how you get the b value in your equation. Okay, so we also kind of look at it as like the slope, so to speak, and a is always your beginning number. Okay, notice your input value x, it's the exponent, and your output value is still y. Now, how you're going to see that in a table format is you might see, okay, I've got my input and I've got my output right here. Okay, and for every input value, I might just increase my input value by 1. But my output value, you're not just adding or subtracting an amount, you're multiplying it by something. Let's just do something very simple and say we've got y equals, let's say, 2 to the x power. And this was in your notes. This x, we can use whatever we want. We can use a positive number, we can use a negative number. If we used a negative number, you get a value that's smaller than 2. See, y equals 2 to the negative 2 power. Remember your negative exponents? You write the reciprocal. It's really 1 over 2 to the second, which is 1/4. So for every input value of negative 2, you get out 1/4. Whereas if I put a value in of positive 2, 2 to the second power is 4. Much bigger output. 2 to the third power is 8. 2 to the first power is 2. Notice that this change isn't adding the same amount each time, but we are multiplying, and in this case we're multiplying each previous answer by 2 to get the next answer. So your output values are a multiple of the previous output. That's how you know you've got exponential growth or decay. So let's practice an example problem here. All right, we've got, oops, that one's all messy. Let's get a cleaner one. Okay, let's say we've got some money. We're investing money, and we want this money to grow over time, and we're not going to touch the money. We're just going to leave it in an account. Okay, so let's start off. Let's say we've got $1,000. Okay, and we're going to put that $1,000 into an account that earns interest rate of, let's say, 5%. Okay, and we're going to leave it in for X number of years. X equals number of years. Okay, well, that $1,000 is my beginning number. That's A in my formula. Y equals A times B to the X power. Okay, now then, my B value is given by 1, and in this case, plus 5%. Now, we are not going to put 5% in as a percentage. We have to change it to a decimal. So we move the decimal and 5% to the left 2 places, and we get 0.05 to the X power, and X is the number of years. So if I wanted to know, how much money do I have after 5 years, I would type into my calculator 1,000, 1.05. Notice that that's greater than 1. That's why we have growth to the power of 5. And then we put that into our calculator, and it'll tell us what our dollar amount is worth. This 1 times 1,000, that will give us our original number plus the 5% compounded interest over 5 years. Okay, so that's how, and then I could change it to 10 years. I could type in 30 years, whatever I want to for that exponent. Let's do a decay problem. Let's say that over time, I bought a car, and over time it depreciated in value. So the car, it cost, we'll say, $30,000. And as soon as you drive it off the lot, it depreciates in value. So it loses, we'll say, 12% value every year. So what we would do is we would say, okay, I want to find out what my car is worth after 3 years. I would take my starting value of 30,000, 1 minus 0.12, that's my rate, change to a decimal, and I'm subtracting because it's losing value. And then I could say to the X power, and if I wanted to know what it was after 3 years, I would put 3 in there. Now, for your calculator, you don't have to type this into Y equals. If I want a specific number, I just type this into the calculator and let it do the computing for me. Now, you can type in parentheses 1 minus 0.12, or just type in 0.88. And notice that's your B value, and it's less than 1. That's why you're getting decay. Okay, it's shrinking. All right, those were the main points that I wanted you to get out of your calculator, and being able to put the information in your calculator to compute your answers. You will need it to complete your homework, and if you have any questions, I will be there for tutoring after school today, and also I should be there the rest of the week. Thanks, guys.